routing. As we have seen in previous video how we can do L2 routing, today I will discuss about L3 routing. As we have know that in TCP by IP stack we have 5 layers, and on layer 2 we do L2 routing, on layer 3 we do L3 routing. Okay, so layer 3 means network layer, and on network layer we do L3 routing, and the famous protocol on network layer are IPv4 and IPv6 are the two famous protocols that we have on network layer. Okay, so then then why we do L3 routing? Then we have L2 routing. Then what's the difference between L2 routing and L3 routing? The difference between L2 and L3 is that in L2 routing we can send a packet within a subnet, not outside a subnet. But in L3 what we can do, we can send a packet from a source subnet to the destination subnet. This is the advantage of L3 routing over L2 routing. So okay, you might have got the idea of L3 routing. So I will explain actually how L3 routing will happen. In L2 routing, as we have as you might know that previously we have discussed in the previous video, that L2 routing purely done on the basis of MAC address, while for L3 routing IP addresses were used. IP addresses were used to send a packet from a source subnet to the destination subnet. As you can see, we have to explain the L3 routing concept. I am using a simple example to explain you how L3 routing done. As you can see from the above topology that we have 5 nodes P, Q, S, P, Q, S, R and T. Okay, we have it. I'm using this topology to explain the concept of L3 routing. Okay, so this is a simple topology. In that topology we have 5 nodes P, Q, R, S, T. Okay, this were the 5 nodes that we have. Okay, now the situation here is, suppose P received a packet and it wants to deliver the packet to the T. Then how P will forward the received packet to the T? Will it transfer first to the P, or P transfer to the R, or P will transfer directly to the T? How P will send the packet to the T? Okay, how it will achieve this? achieve this goal of sending a packet from P to T, and we can achieve this goal by we can achieve we can achieve this goal by feeding L3 information in every router, every router of the topology. That means we will feed L3 information in the QSRT, so that whenever a packet receives, it will have a packet will have its destination address and the next hop address of it. See, this is how we fed L3 information in L3 routers of the topology. In Q, we have fed the information TS as L3 information. In R L3 router, we fed the information T and S are the L3 information. Then if a packet arrives at P and it wants to deliver the packet to the T, then what route it will take? It will go from P to Q, and from P to Q and Q to S and S to T. This is how a packet will travel from P to Q and Q to S and S to T. This is the way, this is the path that it will take, and how this is the path we are feeding into the L3 routers, so that this is the information we are feeding in the L3 routers, so that whenever a packet arrives at source address, it will deliver to the destination address. So the L3 information carries two parts in it. First part is the destination address and the next hop info. Next hop info means the next node which is available. So whenever a P receives the data, whenever a P receives a packet, it will know how it can transmit the packet to the destination T. So this is the way by which L3 routing happen. So this is the way. So this is the way by which we feed L3 information in every router, so that all the routers work together, so that to deliver the packet accurately to the destination address. Another example I will show you. Here we have a topology. In this topology, we are having 8 devices. M, N, L, R1, L3 router 1, L3 router 2, P, O, P, Q. So this were the 8 devices we have, and and every device have a MAC address. For L device we have a MAC address as ML, and for M device we have a MAC address MM, and for N device we have a MAC address as MN. For router, for L3 router R1 we have a MAC address of MR1. For L3 router R2 we have a MAC address of MR2. Similarly, all the devices will have a MAC address. And this topology also have a subnet, source subnet A, which is 11.1.1.0/24, and a destination subnet B. So suppose N wants to send a packet to the P. Now the device N, which wants to send a packet to the device P, but the thing is here, N is in a subnet A, and P is in the subnet B. So they are not in the same subnet. Okay, if it is in same subnet, we can do L2 routing, and then the packet can easily transfer from source to destination. But here the problem is both the source and destination addresses are not in the same subnet. They are present in different subnet. So because of that we are using L3 routing. And as you can observe, in between the subnet A and subnet B we are having an internet connected between it, and here we mean internet as a finite number of L3 routers available in between it. We define internet as a finite number of routers available okay, you might got the point what I'm trying to say. We say internet as a finite number of L3 routers are present. Okay, our goal is to send a packet from a device N to the P. How it can be done? First, the source machine will send a packet. First, the source machine N has to send a packet from device N to the gateway router R1 to leave is okay. Our goal is to send a packet from device N, which is present in the subnet A, to the device P, which is present in the subnet P. So first the first step will be the packet will be sent from device N to the router R1, and this process is done with the help of L2 routing only. Why? Because L2 routing done only within a subnet, and then in the second step what we are doing, in the second step the packet will travel from router R1 to the router R2 with the help of L3 routing. So in the third step, in the third step what we will do, in the third step we are sending packet from the gateway router R2 to the destination device P, and this process is done by using L2 routing. Why? Because it is present in the subnet, so in the same subnet. So you might get the idea of how L3 routing is done and how L2 routing is done, and difference between L2 routing and L3 routing. So this is a simple practical example, so that you can understand what is actually L2 routing, how actually L2 routing and L3 routing is done. Okay, at the end of the video we will write a Python script in a Mininet, so that you will get a idea of how L3 routing will be done. And if you have any doubt regarding what is subnet and what is Mininet, how to install Mininet, and how to use it, so for all this thing I will mention in the description the links, so that if you can read it, you will get it, how to install Mininet, how to use it, what are the basic commands of Mininet. Okay, if you have any doubts like about L2 routing, about Mininet, how to install it, the next thing I will explain you about the IP address. So in L3 routing, IP address plays an important role, but in L2 routing MAC addresses play an important role. This is the difference between L2 and L3. So the full form of IP is a protocol which have the responsibility of transport the data in a packet, and the full form of IP is Internet Working Protocol. So this is the full form of IP, and actually IP is also a protocol which send a data in a packet. So also at the network layer we are having two famous protocols, that is IPv4, which is IPv version 4, which is a 32-bit address, and IPv6, which means IP version 6 is a 128-bit address, and they are unique. And when I am saying unique, what do I mean by that? I mean every device which connected to the internet will have one and only IP address. That means two devices connected to the internet will not have the same IP address. So this is the concept of unique. Unique means that no two devices will have a same IP address over the internet. So this is how IP plays a role in addressing. So some basic rules, I will explain you some basic rules for IP addressing. Suppose we are having a IP address IP address as 192.016.4.48. So what's the problem in this network ID is that there should not be any zero in initial of the initial of the bits, initial of the IP, such as like here we are having 016. A IP address should not have any initial 0 in its IP address. Okay, so another thing is that a IP address should have at least 4 numbers, not more than that. Here here we can see we are having 5 numbers: 192.168.1.10.8. It should not be always. We should IP address should have 4 numbers, not more than 4. More than 4. If it is 5, then it is not valid IP address. Then the third thing is that in an IP address, a number should not be a number has to be equal to 255, should be equal to 255 or less, not more than that. But here you can see we a 401 is there, so this is not a valid IP address. Okay, now I will show you the concept of MAC. What is mask? Suppose we are having a mask value 220 in decimal form, 255.255.255.0, and this thing you can represent it in binary form as in 8 ones, and for 0 you can represent at 0. If you can add this 8 plus 8 plus 8, it will become 24, and that we call it as a mask value or CIDR. And the full form of CIDR is classless inter-domain routing. Okay, this is how this is the concept of mask value. The IPv4 protocol has the concept of careful addressing, where IP address will be divided into 2 parts. First part will be network ID and the host ID. A mask is a 32-bit number which will determine which part of the IP address is network ID and host ID. For example, the mask value 255.0.0. which can be represented in binary as 8 ones and 8 zeros, 8 zeros, 8 zeros. The 8 ones is a network ID. This is the network ID, and the remaining part is the host ID. Why? Because 8 bits are ones, that means the 8 bits are network ID, and the remaining 24 bits are remaining 24 bits will be host ID. Let's see another example. Suppose we are having a mask value of 255.255.255.0 by 24. And suppose we are having an IP address as 202.100.133.16. then what is the network ID of it? the network ID will be 202.100.1.3. Why? Because we have a mask value that contains the first 24 bits as a ones. As you might know, binary value for the 255, it will be 8 ones. So that means this number will be valid for the network ID, and similarly this is also valid. 100 is also valid, 255 is also valid. So the network ID will be 202.100.133. so 0 means it will be host, so 16 will be host ID. Next example, you can see the mask value 8 can be represented in decimal form as a 255.0.0, and in binary form we can represent it as 8 ones and 80000. As you can see clearly here, 8 can be represented in decimal form as a 255.0.0, and in binary form 8 ones and 0.0.0. so here we are getting 8 because we by adding these all ones. Similarly you can also represent 16 as 255.255.0 in decimal form, and in binary form 8 ones and 8 zeros and 8 zeros, and if you add this once you will get 16. Similarly, if you add the you can represent the mask value or CIDR, which is classless inter domain routing 24 in decimal notation to 255.255.255, and in binary it will be 24. It will be 3 8s, and 3 8s will be 24. Similarly 21, like 21 you can represent in a decimal form as 255.255.248, and that can be represented in binary form as, and the thing is that you need to count the number of ones here. 8 plus 8 is 16, and plus 5 it will be 21. Always a mask value or CIDR will be denoted by slash. So what is a loopback interface then? So loopback interface is a software interface. It is not a physical interface that is dependent on the hardware. So loopback address is a software interface which is not dependent on the physical address of the hardware. Suppose for network, every network card will have its MAC address burned on its hardware, but here loopback interface is a software interface which is not based on the hardware, so you can create as many as you like. Also a loopback interface will have a MAC address and which is configured with the IP address. The main purpose of loopback interface is for reachability of the device. why do we need a loopback interface? So as you might know, only IP addresses will have only interfaces will have an IP address, not the machines, not the machines. So to identify the machines, we are using loopback interfaces so that to identify a machine. Identify a machine and assign a IP address to it. Every interface will have IP address, but machines won't have. So with the help of loopback interface, we are assigning a IP address to the machines. So this is the concept of loopback interface. Okay, let's see how L3 routing is done in Mininet with a simple Python script. In order to explain L3 routing, I'm using a simple topology, and I will implement this topology with Python in Mininet. Okay, so you can see we have a topology, and this topology have a three L3 routers, R1, R2, R3 with loopback addresses. R1 has a loopback address of 122.1.1.1, and R2 similarly, R2 and R3 also have a loopback address. And we have 4 subnet: subnet 1, subnet 2, subnet 3, subnet 4. And the topology also have 2 hosts, host H1, host H2, and they do have loopback address. So this is a topology we will implement in Mininet with Python. Okay, so this is my Mininet machine. First I will see what folder I will save the file. I will save my files in Mininet. Programs. Okay, and if you don't know what is Mininet and how to install it and what are the basic commands, then you can check in the description, so that you will know, check in the links in the description, so that you will know the basics of Mininet and the commands which we use to explore Mininet. Okay, now what I will do, I will create a Python file with command cat greater than demo1.py. okay, and press enter. The file is created. Now what I will do, I will copy the code and paste it here. And to paste the code, you just need to right click it and press OK. Okay, this is my code. Okay, this is our code, and what we did here is we imported the Python APIs for network creation and for doing L3 routing in Mininet. And what are the Python APIs here? Look, from mininet.net and mininet.ci and mininet.link are the 3 APIs. And it is, look, the next line is if main equals to main, means it's a Python function where execution of the program start. First what we will do, we will create the physical entities of the topology. Okay, to create the physical entities, what we are doing, we are taking a variable as net and creating a instant of net by mininet. Okay, then we are adding two host h1 and h2. Then we are adding three L3 routers, router R1, R2, R3. Then what we are doing, we are adding links. And we are adding 4 links from h1 to r1. You can see till now what we have done. We have added 2 hosts, h1, h2, and we added 3 L3 routers. Now what we are doing, we are adding 4 links from h1 to r1 and from h1 to r1, from r1 to r2, r2 to r3, and r3 to r4. These were the 4 links we have added. Look, h1 to r1, r1 to r2, r2 to r3, and r3 to h2. These were the 4 links we have added. Now what we are doing, look, we have at this instant what we will do is, look, and also when we are adding 4 links from h1 to r1, we are also adding interface name also. h1 Ethernet 0 and second interface r1 Ethernet 0. Look, h1 Ethernet 0 and r1 Ethernet 0. So these were the 2 interface. We are naming the interface name also when we are adding links. Okay. Next, look, as we have added all the physical entities of the topology, now we will write a net.build to build the topology. Next, what we will do here, from here we will start configuring the till now we have just built the topology. From here what we will do, we will start configuring all the device in we start doing configuration on the devices. First what we will do, first we will remove the default IP addresses from the host h1 and h2. Default host addresses which were given by the Mininet. Then next what we are doing, first we remove the default IP addresses from the host h1, h2. Then what we are doing is assigning our desired IP address to the host h1 h2. Similarly what the next step we will do here is, first we have remove the default address, and then we assign IP address of our choice to the host machine h1 and h2. Now we will install the default routes on the host h1 and h2. Next, what we will do, we will configure the loopback address for the host machine h1 and h2. Configure the loopback address to the h1 and h2. Okay, till now what we have done, we have removed the, we are doing the configuration only on the host machine h. First we remove the default address, then we assign IP address of our choice on the host machine h1 and h2. Then in next step what we have done is we have configured the default routes in the host h1 h2, and then we configure the loopback address to the host machine h1 and h2. Then what we will do is, as we have finished with the host machine h1 and h2, then we will configure the router r1. Configure the router r1. First, what you will do, first you will remove the default IP addresses, default IP interface by these two command. Then configure the IP address of your choice to the interface of the router r1. Similarly, you can also configure the loopback address. Okay, first you need to remove the default IP addresses from the router r1 interface. Then you can assign the IP address of your choice. Then you can you assign, then also you can also assign a loopback address. Similarly, you configure the r2 router. First remove the default IP address by this upper two commands, then assign your choice of IP address interface, IP address, also loopback address. Similarly, for R3 also you remove the IP address, remove the interface IP addresses of router R3, then assign the IP address of your choice, also loopback address. Okay, so we have configured the 3 L3 routers. Then this is the interesting part of L3 routing. In L2 routing we haven't seen like this command echo 1 equals to. This is the main command that plays important role in L3 routing. So one more important thing to note here, this is the path, this is a path in Linux. Okay, and so when we are starting our program, I said net is a variable. So net is a variable, so it is not the net. I said it is a variable, so it is, so if you assign your own variable, then don't change the path, What do I mean by that? Means when I in the beginning of the program I assign variable as net, so it is not the same net variable here, so don't change it, so don't get confused with this. Okay, and we used this command to enable IP forwarding. And when we use 1, it means we are enabling the IP forwarding on the Linux. If I kept 0, then it will disable the IP forwarding. Okay, and this command help the router to work as a L3 router to exchange packet between two different networks. Okay, so this is the important command that helps L3 routers to send a packet between two networks. Okay, all the routes in the routing table to how to reach a loopback addresses from the router R1 for route to H1 and R2, R3, and this were the routes through which router R1 can reach the other devices in the topology. And for the subnet, and similarly do for router R2, router R3, and host H1 and host H2. So this were the routes. We are installing the routes in the routing table to reach every device in the topology. Okay, and this is net.stop to stop the emulator. Now what we will do, as I have explained you all the script, and I don't like to type all the script by hand because I feel it will take time to type all the script by hand, so that's why I just copied and pasted it. So you can also do it by the same way, but the thing is that you need to understand the logic, just simple logic, so that you can also write the same programs. And the important thing is here, it's not any kind of algorithm, we are not using here any kind of algorithms or something. We are just using a simple commands. Okay, to compile the program, press enter and Ctrl D. So the command which we will use to compile the program, sudo python, and our file name is demo1.py. Okay, we have successfully compiled our program. Now next what we will do, you can use the same commands, same simple basic commands of Mininet, such as links, net. You can analyze the topology which we have created. And nodes H1, H2, R1, R2, R3. These were the two host machine and 3 L3 routers. Okay, similarly, okay, now we will see, can we ping H1, ping. Yes, you can see we are able to ping the host machine H1 with the H2. Okay, to exit from this ping command, press Ctrl C. Now I will ping H1, ping R1. Yes, I'm able to ping host machine H1 with the router R1. Similarly, you can check all the devices from the topology, whether you can able to connect it or not. Okay, you can, then also you can in L2 routing. In the previous video I have shown you some more mininet commands, so you can also use that commands to analyze this topology, and you can check, and you can check the routing table of host H1 with the command and for router R1. Similarly, you can check all the devices like host H1, H2 and all 3 routers, and you can check IP configuration and interface of your device. Like, so I have written wrong command. So you can check all the interfaces of your devices, like for router R1 also you can check if okay. This is the end of the video. So I have explained you how to do L3 routing with the help of a topology. Okay, then bye for now.